Welcome to BioMR, a bioresponsive VR system. BioMR consists of three components: biometric data, an application programming interface, and a virtual reality scene. The system works as follows. First, biometric sensors are attached to a VR user. These sensors measure physiological levels such as heart rate. A third-party application, iMotions, compiles the data and uses our API to communicate with a game engine, which is running the VR scene. We have implemented a user interface to help a researcher configure the API. A researcher can specify triggers in the API, which will automatically modify the VR scene once a threshold sensor level has been exceeded. We have created two test scenes, one in Unity and one in Unreal Engine 4, to demonstrate that our API is compatible with multiple game engines. Now we will demonstrate BioMR in action. The setup in the graphics lab uses the HTC Vive head-mounted display. The VR subject wears the Shimmer GSR sensor and uses the HTC Vive motion controllers. The subject's movement is tracked using the Vive's base stations. All software is ran on the powerful lab PC, which has a Titan RTX and a 9900K. Next, we configure iMotions to automatically forward all sensor information to the API. The communications take place on port 60,000. On the same computer, we also run the BioMR API. The researcher can manually change game engine parameters or set automatic triggers which will change game engine parameters based on sensor levels. Creating a new trigger involves choosing a sensor, a threshold value, and a parameter in the game engine to change. Now we will demonstrate manually changing the rain intensity in Unity. Setting the spin box to 0 sends a signal to Unity that the rain should be turned off. Now we will demonstrate an automatic trigger in Unity. We make a trigger that states if the shimmer reads a value greater than 1500, we will set the rain intensity to 1. The rain intensity automatically changed to 1. Now we will demonstrate the Unreal Engine task system. The researcher clicks Create Fetch Quest, and a new quest is created. The subject now navigates using teleportation to collect the requested items. When all items are collected, the task has been completed. Now we demonstrate manual parameter control in Unreal Engine. The researcher can manually turn rain on or off. They can also change the day length, which modifies how fast the sun moves through the sky. Now we demonstrate an automatic trigger in Unreal Engine. First, we click Add to make a new automatic trigger. Then we choose the event source, which is the heart rate monitor. We tell the API to watch the heart rate data, and if it exceeds 100, we will set the rain intensity to 1. Now pay attention to our user's heart rate. When it exceeds 100, the rain intensity will automatically change. Now that the rain intensity has been increased, the user's heart rate has fallen in response. Now we will show how BioMR can be used to analyze data after a study. While the user is in VR, the game engine can use our API to create annotation regions and iMotions, which indicate when users performed certain events. In this case, we display when the user is navigating via teleportation and when they pick up and drop items. This data can be correlated with the biometric sensor levels shown in this plot. This concludes our demo of BioMR.